everyone. In this video, I am going to explain planar kinetics of a rigid body using the concept of work and energy. This is the question I have explained in my previous video using the concept of Newton's second law. In this video, I am going to explain the same problem with the concept of work and energy principle. Work energy concept of a rigid body differs from a particle only in two aspects. The first one, the rotational kinetic energy. The second one, work of a couple. When the rigid body is rotating about the fixed axis, the body has both translational and rotational kinetic energy. However, a particle is always subjected to either rectilinear or curvilinear motion only. Hence, the kinetic energy of a particle due to rotation is always zero. This is the main difference between the kinetic energy of a particle and a rigid body. The second main difference between a particle and a rigid body is work of a couple. It is impossible for a particle to have a couple. Hence, the work of a couple for a particle is always zero. Whenever a rigid body undergoes a fixed point rotation or a general plane motion, in addition to the force, a couple also do some work on a rigid body. But when a rigid body undergoes only translational motion, the work of a couple on a rigid body is always zero. And couple is nothing but the force into perpendicular distance, which causing a rotational effect. I have already told you to solve any problem in dynamics, it is always better to draw the free body diagram and kinetic diagram of the given arrangement if possible. Free body diagram is a diagram in which all the supports are shown by its reactions. This figure shows the free body diagram of the given arrangement. The weight of the disc 294.3 Newton act through its center point O, and point O is also pin jointed, hence it have two reactions, one act horizontally and other act vertical directions that are marked by OX and OY. Now we are ready with free body diagram. Hence I am going to apply work energy equation for this free body diagram. The first equation represents the work energy equation, where T1 is the initial kinetic energy, T2 is the final kinetic energy, m into theta work done by a couple, F into S work done by a force. Applying all the data available in the free body diagrams, we will get theta equal to 17.1 radians. Dividing by 2 pi, we will get the number of revolutions. Thank you.